everyone, Katrina here, and today I'm going to show you how to solve challenging trigonometric integrals using U-Substitution. Be sure to watch to the end to see the full example and subscribe for more videos. So we're going to jump right into an example so we can see how this is done. Let's consider the integral of cotangent x multiplied by cos squared x, and we're integrating with respect to x. So the first thing we want to do before we perform any substitutions is see if we can simplify or change the way in which this integral is expressed so that it makes our substitution more powerful. So right away we can see that cotangent is the equivalent to cos x over sine x, because we know that tan equals to sine over cos, and tan is the reciprocal of cotangent. So let's go ahead and put this substitution in right away. Because I find it's always nicer to deal with integrals that have the primary trig ratios instead of the reciprocal ones. So as a result, we've got cos x over sine x multiplied by cos squared x dx. We can go ahead and combine this to further simplify it, such that we have cos cubed x over sine x dx. Okay, now what can we do? So we have sines and coses in this problem. So the best thing that we can do is convert one of our coses, or as many as possible, into sines. So how can we do that? Let's go ahead and rewrite this integral once more. So we have cos squared x multiplied by cos x over sine x. And this is still with respect to dx. And we know from Pythagorean's identity that cos squared x plus sine squared x equals to 1. So that means that cos squared x equals to 1 minus sine squared x. Let's go and import that right over here where we have our cos squared x. So as a result, we now have the integral of 1 minus sine squared x over sine x multiplied by cos x dx. Now we're at a stage where we can perform our U-substitution. So we're going to say let u equals to sine x, and then du is the derivative. So derivative of sine is cos x dx, and we want to isolate for dx, so that means that dx equals to du over cos x. So this is great because we can see that when we do this substitution and we put this in for dx, our two coses here are going to cancel out. So what are we left with? We're simply left with the integral of 1 minus u squared over u du. Okay, so let's go ahead and actually split up this rational expression so that we have 1 over u minus u squared over u du. We can separate this integral so that we have the integral of 1 over u du minus the integral of, we can simplify this here. This u cancels out with this one here, so we simply just have the integral of u du. Okay, so this is pretty simple to solve. So the integral of 1 over u is the same as ln u, and then we have to now subtract the integral of u, which is u squared over 2, and then we have to remember our very important plus c value because this is an indefinite integral. But we're not done yet. We need to sub back our substitution. So we said that u equals to sine x. So wherever we see u, we just have to put a sine x. So that means that we have ln, absolute value, of sine x, and then plus sine squared x over 2 plus c. And that is our final answer. If you enjoyed this video, please make sure to give it a like, Comment any questions that you have, and please subscribe for more fun math videos. I look forward to seeing you next time.